the way, I'm Nikunj Doshi. I have been like a DevOps engineer, a software engineer, and my last role was a solutions architect. So I worked in various IT companies, and that actually motivated me to come up with this topic. But before I start my presentations, I want to give a big shout out to Paul Bruce and Don, both because both of them inspired me to be on this stage. I've been associated with DevOps this Boston for past 4 years now. So I've been like a volunteer, an attendee, and this is my very first time being on the stage, like from this stage to this stage here right now. It's like an exciting journey for me, so I'm pretty much excited and hope that you guys are as well. So my topic is building resilient pipelines and how to handle disaster recovery, chaos engineering. So just want to quickly walk through the agenda that I'll be talking in detail about what exactly fault tolerance is. If you are a DevOps engineer, then what are the ways you can design resilient pipelines, how to deal with the disaster recovery and business continuity process. And lastly, I will also emphasize on chaos engineering, what are the different practices, and give takeaways for the last moment. So before I begin, I just wanted to know the audience, who are software engineers in the room? Can you show up hands? Oh wow, that's like a decent amount of hands. Any DevOps SRE guys? Wow. And solutions architects? Wow. Oh, yeah. I have compiled for everyone. So my basic topic here is more on the basic beginner to intermediate level. So I hope I try to cover everything. Like yesterday I learned some of the audience are also in the early stages of their DevOps and engineering career. So I have curated the content in such a way that it's feasible and it's understandable for everyone. So just wanted to give a quick overview about myself. I came to USA 5 years ago. I pursued my master's degree simultaneously. I also got a master's in business administration. So that actually gave me a blend of both the IT domain knowledge as well as the business overview knowledge. And that actually inspired me to look on the broader perspective, like a solution architect level or any TAM roles. So previously I worked as a Cloud DevOps Engineer at a company called Attendees in India. And then when I came to USA, my role were more niche, more into domain broader aspects. So I started working as solutions architect in Red Hat. Apart from that, I've always been a DevOps and cloud enthusiast, so I've been associated with DevOps this Boston and various other communities in Boston. So that always keeps me motivated to learn new things. And I also got certified in various tech certifications like AWS Solutions Architect, CDA, Cloud Practitioner, then Google Analytics, Tableau. And then one of the other certifications that actually helped me for this particular topic was from PagerDuty, the incident responder certifications. So this is a very high level overview about me. So now let's jump and deep dive into the topic. So every IT engineer, they always have a success story, but moreover, behind those success, we all know the stress and the pain points which we go through. I am sure, if I were to ask a question to the audience, how many of you have been stressed when you are about to do any kind of deployments? Any raise of hands? Yeah, I'm pretty sure. So actually, I could have put my photo over here, but I don't actually have one. Rather, I have seen, I've been all this many a times. So in India, when I was working as a cloud engineer, I was working for migration projects. And if you were to do any kind of lift and shift production migration, I can surely tell how much would be the stress and toil on your top of your head. You can imagine. My clients were from fintech industry, healthcare industry. So we would get a specific amount of time only where we would be doing rollovers and cutovers, and then we could not even take a risk of doing any business process critical mission activities during that time. So I used to sit like in my office. We had like a 48-hour dry run, and that too on the weekend. So one can imagine how like a stressful job it would be. But moreover, beyond those stress, I got to learn various concepts like business continuity process, disaster recovery. I mean, those are like really big coin IT terms. But moreover, when we deep dive into this, there is like tons and tons of things to know about. I'll try to cover most of the things when it comes to fault tolerance, how to build those resilient pipelines, how as a DevOps engineer or an architect, like how we could develop those pipelines. So as I told, like why this topic is important in DevOps, can anyone tell like what would be like the key aspect like of how fault tolerance would be like a thing without which we cannot complete our DevOps activity or a successful checklist? So I'm a combination of Gen Z and a millennial. So I always like meme culture has like always inspired me. So I'm sure like all of you engineers would have come across this kind of memes when the code is in a mess but it's working anyway. And the first rule of programming: if it works, don't touch it. Yeah, these are like the most common memes which we already have come through. But yeah, this is like our day-to-day practice, and then many times like we always try to ignore something, but then there are like instances or scenarios which we cannot ignore. So this is what like I'll try to cover in detail. And just for anyone like who's in the beginning stage of their career, if anyone wants to know like what's fault tolerance and why it's crucial in pipelines. So just to give you overview, fault tolerance is the ability of a system to keep working even when one of the components fail. So when one engineer designs or when a developer is working on a piece of code, there are many times that there would be a scenario where like if the code is working in the staging environment, but why doesn't it work on production? Then we would be start to debugging like, okay, in this environment, like what are the parameters which are missing? Like what kind of API calls were not invoked? So this is what like we start debugging into. And some of the common failure scenarios, if we were to look at, are like infrastructure redundancy. Then other more important scenarios are like data handling and backup. If we do any kind of data handling and backup, there are instances where like one of these component production issue will come up or the other. And finally, like we always have to like come up with these strategies like when it comes to error handling and recovery. So like now we have understood like in a nutshell like what is like a fault tolerance, but what are the ways like how we could debug and design? So here is like we can look into this. So we will have to understand like what are the key components for fault tolerance, what are the ways and mechanisms how we could debug them. And then I would also like to highlight some of the important case studies like some of the FANG companies, MANG companies, and how they are like actually they have come up with these strategies and solutions for this. So let's understand some of the key principles. Like most of us are like engineers, and even if we are engineers, like we still have to understand like in theories like how actually like it would be helpful. So when it comes to redundancy, then we always try to invoke multiple instances. If you are running any kind of Kubernetes workloads, I'm sure like you would be spanning your pods and nodes in such a way that like you will end up like doing multiple replications. Then other thing, what are like the failure mechanisms? Like if one of your instances is running in one region and let's say that region goes down, then what are the other ways like how you can quickly turn up? So that is like another important strategy which any engineer would have to understand. Then graceful degradation, like some of the functionalities, like if you are building an e-commerce platform, some of the functionalities might work in some aspects, but maybe let's say this is like a scenario which I have encountered. How many of you have ever worked with e-commerce clients? Anyone here in the, yeah, I see a handful amount of hands. So let's say right now like we are in the US region. and the way the payment system works in USA is different in Europe. And this kind of situation always arises, like in Europe, for every country, they have a different kind of currency, or even in the Asian countries. So like there are always issues, like when you are like working on full throttling, there could be instances like where some of these payment failures are bound to happen. Then we are always liable to do monitoring and alerting. So this is like a very important aspect when you are doing. If you don't have monitoring tools, or like if you haven't like built those monitoring, then the very first step like when it comes to do the fault tolerance is like having the monitoring and telemetrics. Then decoupling components is also like really important thing. When there are like if anyone is into software development, like we all understand, like we have front end, back end, then we have middleware layer. So how you actually decompose, like same applies for the building DevOps pipelines. So like you have to set substrate strategies for back end, front end, etc. Then we, as I told about data replication and handling, the other thing which I want to emphasize more is capacity planning. How many of you know like horizontal scaling and vertical scaling? Most of us, right? Then how are like the strategies which we are going to implement? Like how are you going to predict, okay, like this are the ways, like are the scenarios when like the load will be higher or the graphs. So as I told earlier, like we do set up monitoring and telemetrics for that, but capacity planning is like really important strategy that will helpful. So as I told, like I earlier used to work with e-commerce clients, then many times like this always is like a problem for us when we are not able to find out, okay, for certain times, like let's say if we are working on a Thanksgiving sale rated scenario, we are knowing that from November third last week to the first week of December, the load on the servers would be high. So we try to spend those pods and nodes accordingly. But then there are like certain scenarios where we cannot predict, okay, the load on the instances would be much higher than predicted. So try to work on those scenarios like where we could like span out and span in, and this is how we can like try to plan the capacity. And lastly, I want to emphasize on documentation and training. I mean, this is like a generic IT practice, but if we have a strategy and documented, this would be helpful for all other team members. So as I told about some of the mechanisms, let's understand some of the strategies, how we could actually help and design these strategies. So this is like a high level thing, strategies to handle the fault tolerance. So one of the thing is like defined requirements. All we are like, most of us are in the engineers in the room, but if we were to like, promote ourselves, like let's in the future, like we would be all in the IT leadership roles. So the way this particular topic is designed that way, that like anyone who would be in the IT leadership role, or if anyone would be like advancing into their career into senior roles, like what are the ways and strategies which they could handle. So very first step is like design requirements. So we will have to understand what are the key business needs and determine availability goals. So most of the time any healthcare application or any finance application, the service level agreements is like 5 nines. I'm sure like everyone in this room would be aware about like what are the SLAs and 5 nines. So this is like a really important requirement for any engineering team to take care of into consideration. Choose appropriate architecture. So obviously everyone in this room would be aware about like microservices and monolithic architecture. So when we are designing components or when we are designing those DevOps pipelines, we'll have to take into key considerations like how we could actually deploy those components in such a way that like any server goes down or any component goes down, like we still could actually try to bring those replications available. And then Right now, what we are seeing in the industry is like a massive shift of serverless computing or event-driven architectures. So many a times, like are using Kafka or another messaging queuing systems for responding or like decoupling these events. So this is like really one of the way like how we could actually design the fault tolerance systems. Then implement redundancy, hardware redundancy and data redundancy. So for hardware redundancy, what we could do is like deploy multiple instances of servers and network components. And so for data redundancy as well, what we could do is like master slave or multi-master databases to ensure data availability. So most of us like would have obviously like designed this in our day-to-day scenarios, or would have come across this like in for Kubernetes or for container deployments. Same thing, like when we are designing architecture, we have to ensure that like we always have like n number of nodes. It could be just odd number nodes. So design for failover. So load balancing, everyone knows like how actually like we do load balancing, what at application level or at server level, what are the different ways and scenarios like we could implement them. Then automatic failover is also like a really important thing which we can do for healthy instances. Monitoring and alerts, like we all at every level we usually do that. So when it comes to application monitoring, infrastructure monitoring, what are the different ways? Like let's say for a health check, if the application load is more than 70%, we should start setting up some alerts and triggers. So that way we could set up those alert mechanisms as well. Now that like we have understood some of those mechanisms and strategies, let's see some of the case studies from the tech companies. I'm sure everyone like would have drive here or like anywhere through Uber cars. But like, have you ever seen like how Uber has actually implemented fault-tolerant architecture? So the main reason for that is like they have developed microservices architecture. How they have developed those resilient architecture is like for each scenario, each city, or maybe for each of the states, they have different architecture paradigms for that. So let's say if there is any kind of issues or traffic in, let's say, Boston area, then like they would not be having similar issue in other cities. So this is how like they are trying to keep the microservices architecture at for different regions and like at a granular level as well. Then we all have been using like social media, let's say like Facebook, Instagram. And have you ever thought like how Meta has been like actually provide us such a powerful content every day, and like without having any kind of outages. So the main paradigm which they are using is high availability. And when it comes to high availability, like they are using distributed architecture systems. So all those real-time data can be easily replicated instantaneously within the seconds. And the way it is designed that like even if there is any kind of outage or failover, then they could actually help it. So let's say like if you are posting one post on Facebook, it would be easily getting replicated, like thousands or millions of people can see within seconds. So that's how like through high availability they have designed these concepts. So we should not forget at any point like disaster recovery, business continuity. So like understand that in details. Once we know that we have like developed fault tolerance systems, now we have also understood like what are like the ways to design those resilient pipelines. But then like the main component which will come here into consideration is disaster recovery and business continuity planning. Like we all know like disaster recovery, we all know business continuity planning in a nutshell. But then when it comes to implementing that in DevOps, what are the ways we could actually implement that? So I'll not go over like the whole details because this itself like is such a very huge topic. But if we were to understand that in a nutshell, that like what are the key components, then we have to understand RPO, that recovery point of time, and the time to recover object. So RPO and RTO are really important metrics which one has to take into consideration: recovery point of time and recovery time to object. So what is like that one specific point where data loss can be acceptable. So for any healthcare company, it could be just like 1 hour. Beyond that, it could be any issues or instances of time. Then other thing we also have to consideration is business continuity planning. And like what are the key strategies for that? So, I'm sorry. You see, failures can happen any point of time in your presentation as well. So I also wanted to emphasize on chaos engineering and its practices. So one of the things which I wanted to emphasize here was chaos engineering, that what exactly chaos engineering is. So in chaos engineering, like you design the system in such a way that like any one specific system or any one specific component, let's say it fails, then how it cannot affect other systems. So there are like various tools for that, doing that chaos engineering. One of them is litmus test. If you have you heard of Gremlin? Anyone? Yeah, there are like few companies. So and like other important tool which we all should take into consideration is Chaos Monkey. It's designed by Netflix. So other case study which Netflix has, how it has implemented is like using some of the infrastructure paradigms. Let's say like in Netflix, if you are not able to see one of those services, let's say like if you are not able to successfully look into one specific genre of shows, but it should not affect other kind of genres as well. So same thing you can try to implement in your workloads as well. Let's say like if you are dealing with any customer project, so if one of their database services is down, that it should not affect any cloud related service. So this is how you can try to look into that. And lastly, like I just wanted to like give some important takeaways. Like some of the key takeaways are building resilient pipelines, what we understood today, like what are the different ways and architectures, how to build one. Then if you are planning to implement those, then you will also have to consideration into monitoring techniques at every level, not just like within the ecosystem level, but like everywhere, right from application level, pod level monitoring, to nodes level, to container, to Kubernetes architecture. So all those monitoring aspects needs to be considered. And lastly, like I just wanted to like thank everyone for like being such a nice and patient audience. I hope you really get to take away a few of the important topics and paradigms from this particular topic. Thank you so much. Yeah, I wanted to share my LinkedIn, but if anyone wants to connect with me, like one can connect with me on LinkedIn. I had like a QR code in my presentation, but sorry, chaos can happen anytime. Chaos, anyone doesn't like chaos, but chaos likes you. That's why it's always chasing you.
We do have time for a couple questions. If you want to, do you want to do Q&A?
Yeah, sure.
All right. Yeah, we got time for a couple questions. If anyone has questions, and we're doing hoodies for questions. So up top, do we have a mic up top?
I could just yell too.
Great, love it. Me too.
It's an easy one. This is more of a general question for the conference, but are some of the slides and the contact information for presenters going to be on the site?
I think we'll try to share it in the Slack, maybe?
Yeah.
Is the slides going to be on the site?
We'll have video recordings of everything in about 2 to 3 weeks, so yes.
Yes, in some capacity, for sure. Yeah, so definitely the recordings, and we'll try to track down the slides as well. You're welcome to drop a link in Slack later, too.
One can connect with me on LinkedIn. Like my LinkedIn handle is Nikunj, Nikunj. Last name's Doshi, Doshi, and the number's 23. And you can see like my LinkedIn handle through like diamonds. You can see 2 bright and blue diamonds.
Cool. Any other questions? Yeah, what's up?
I've talked to a lot of people about chaos engineering, and it seems like it's a thing that everybody talks about, but people are like reluctant to implement. Do you have any thoughts on like why there's a reluctance to implement chaos engineering?
Yeah, so personally, like we have tried to implement it at various customer sites. and like their infrastructure. The main reason is like this is like a new trending topic right now in the industry. Like a full-scale ecosystem is not yet developed for chaos engineering. We do have a couple of tools and services which are available, and we are using software testing or application testing or like infrastructure testing at various levels. But then like if we were to like implement for network latency, or like if we go on to implement let's say for any kind of redundant servers, the cost implementation comes in picture, and not every leadership or every senior management would want to start doing that. It's good to like have scenarios and instances planned for that. The cost comes in pretty much handy for every other person.
Awesome. One more question? Yeah?
Yeah, so I'm kind of new to chaos engineering. I haven't had any experience with it. Can you provide some examples of like, how you've implemented and how you've used and learned from that scenario?
Sure. So one of the thing when I was working with an e-commerce customer, how we do like chaos engineering is like usually through their latency. So as I told in my presentation earlier, like we know specific scenarios. Like we just have Thanksgiving week round a block in 1 month of time. So if we were to do the chaos engineering, like we will have to also predict some scenarios, like how many customer spikes would be there. Like it could be like million users coming on e-commerce platform on that particular day or time. So if we were to do like we will create like a dummy scenario. Okay, like what if like we don't have enough bandwidth latency for that, and if we don't have like sufficient load balancing load balancers set on that specific servers, how we could affect our customers, what will be the end users affection rate, what are like the time to retrieve those and like time to like spin up those pods in servers again. So those are like the specific and generic examples which we try to implement in chaos engineering.
Awesome. Do I see any last hands? I thought I saw one. Okay. All right, guys, give a big warm round of applause.
Thank
That
you.
was great. Thank you. First talk, guys.
Yeah.